All right, good morning, Hawks. Today's Wednesday, May 20th. It's not a nice day out right now. Bless you, T. Not a nice day out today. It's cloudy. We got some rain coming down. Cloudy with some rain coming down right now. It's supposed to, what I saw, was supposed to have a break in the rain around 9 or 10. It's supposed to rain from now to 9. Cloudy, 70% chance, high of 70 degrees today, and that high of 70 degrees is like at 6 p.m. So it's going to be pretty cloudy throughout the day today. Lunch today is on you again. Make sure that if you're in the area where the buses are coming around handing out, delivering food, make sure you're in that area. You pick up some food, a sack lunch for you, for your family, some family members that you're with at the house. Welcome to another edition also of Garage Math with Mr. Garza and T. Today we're going to be continuing to look at area, but then we're going to make a little subtle transition into what we now call surface area. You were finding the area of certain shapes the last 2 days on lesson 4. But now we're going to switch over to finding the surface area of what we are calling a net. Let me write that here. This is a net figure or a net shape. And what this is here, the net is a laid out 3D shape. It's a laid out 3D shape. Here's what I mean. It's kind of like this box or whatever this is. Right now it's a net. This is a net right now. This is a net. If I fold it in its proper spots where it could fold, I could slowly turn it back into the box that it is. Okay, there's the bottom. And then here's the top. Now I have my box. Now I have my box here, and this is what we would consider a 3D shape or figure, 3D figure. And now we're going to find the surface area of these shapes by using a net. I am a little bummed. This was one of my favorite lessons to teach last year. I had a bunch of little paper shapes that you guys got to cut, and you would tape them together. You'd find the surface area on them. It was a really cool lesson I remember doing with Fred, who was here last year. It was awesome doing this with Fred, this lesson with Fred and with the students. It was great. I felt that really helped out. So if you have a box at your house that you could carefully take apart so you could see the net, or a different figure that you could take apart and lay it out, that would be considered the net. A lot like a fishing net. You know, you throw a fishing net, big fishing net, and it lays out. Maybe some of you have an idea what that is. Here, what we have here is a net of a box that is 13 meters wide, 15 meters tall, and then another side over here is going to be 10 meters tall. Now, these dimensions are important because you need to understand the different shapes and how they are, how they are very similar. Here's what I'm looking at here, and I would like for you to look at this as well. Okay, and there it is. And this is right off of lesson 5, which you'll be getting today. On the left hand side you see the box. That's a 3D box. And on the right hand side you see the same box's net. So the shape or the drawing on the right is the same as the drawing or the 3D figure on the left. They're the same thing. We just unfold it to give you a better idea of what you're looking at. And now from the net we could find the surface area of that box. So I put this shape, I just put it right here. So hopefully you could see it a little bit better. Now let me see if I could just zoom into, there we go. zoom into just this here. Let me adjust what I have going on here. Come on. There it is, kind of. You kind of see the bottom. I won't touch that. Excuse me. So let's find now the surface area of these shapes here. There's my blue marker. All right, let me put this here. I know that these sides, this side, and this side, and this side, they have to be the same. They must be the same. They must be the exact same. Actually, it's going to be, take that back. This side and this side are the same. And then we'll put a plus here on this side, and this side are the same. And then we have this side here, we'll put an open circle, or the bottom and the top, excuse me, which are the exact same shapes as well. Now we just have to figure out what is the different sizes here that we'll be looking at. Okay, so if we look at this shape here now, we can find the area of the top, which is 15 times 13. That's 15, that's 4, that's 5, that's 1. It's 195. So this area here would be 195 meters square. So because we said this side and this side are the same, I don't need to measure this side. I know that this is also going to be 195 meters square. Now we could look at another shape here, which is interesting. We got to figure out the bottom and the top, and we also got to figure out their sides, their lengths. We got to figure out their lengths. I know that from here to here, well, that's going to be 13 because it's 13 from here to here. So that has to be 13. It's going to have to be 13. I also know that from here, if I fold this up, these two sides right here, this side and this side, they're gonna meet up and they're gonna be standing together. So that means that this is also this is gonna be 15 right here. All right, it has to be 15 so that my box could have nice straight lines and straight edges and straight corners. So I wonder what it is from here to here now. Well, we do have a 10 over here on this side. Now we have this 10 that's over on this side. And if you fold it right, if you fold it, and you kind of have to visually see how it's going to, where it's going to be. So this 10 here is going to be also right here on this side. 10. Remember, this side and this side are the same. So that means this side here on this bottom is going to be 10 as well, because it's going to meet up with this side, and it's going to also meet up with this side here. This side and this side and this side, they're all the same. When you fold them up, that's exactly how they'll be. So let's find the surface area for this side here. Well, 10 times 15. 10, 15 times 10. 0, 0. 0, 5, 1. That should be 150 meters. So we'll put that there. And then that's this side, so that means that this side here is also 150 meters there. Okay, let me circle these, that one, and then that one there. 150, we're good with this 10 and this 10. Now we got the top and the bottom. We said earlier this was 13 and this was 10. So I'm just writing this here for those of you that want to see the math. Any number times 10. Remember, we just add the 0. This is 130. We'll put that here, and then this top has to be the same size as the bottom. It just has to be there. It's a perfect square, so the sides and the tops are going to be the same. Now we take all of these, just like you had been in the other lessons. We're going to add them up. So we got 195 plus 195. That's 10. That's 19, that's 390 for side and side. This side here was 150. This side here was 150. So let's add those two. That's 300. Then we have the top and the bottom still that we need to finish, which is 130 and 130. We add those two, we get 260. Now we gotta add these three up. And we have, where could I do that? Right, I don't think you'd be able to see that. Let's do it right here. 390 plus 260. This is gonna be 15. 650, and then add 300 to that, which would be 950. So we get where could I write that? Let me write that right here. 950 meters. We're still looking at area, so it would be meters squared for that shape there. So finding the surface area today. I wish you all the luck. If you need any help, I'll be around again. Click on the Zoom link. Send me a message if you need some further assistance. I hope you have a wonderful day. Stay indoors today. Enjoy the company of your family. Be nice. Be smart. Behave. Remember, go Hawks. Have a great day.